Today we're going to be doing ligation. The first thing I want to make sure is that I have all my reagents ready. So I have my proofreading polymerase, my blunted vector, my PJet blunted vector, my T4 DNA ligase. I have my samples, my CAPC samples, JAK-A and JAK-B. And I have my 2X ligation buffer that's already been pre-aliquoted for me. So once I make sure I have all my reagents, the first thing I'm going to use is my 2X ligation buffer. So I'm going to follow the table down on page 69, so step 3 of the ligation protocol. And first thing it says to make sure that we spin this down and mix it very well, right? So we always want to mix our reagents. We always want to spin them down. This is my 2X buffer. Because it's a very small volume, we want to make sure we spin down. And so you can see that it's just there at the tip, very, very small volume. I'm gonna put those here. I'm doing 2 ligations today, so I have 2 of these PCR tubes. So like always, let's go ahead and label. This is gonna be A for JAK-A, and here I have B for JAK-B. So I'm going to follow the table and add the appropriate reagents to it to do the blunting reaction. So the blunting reaction is the first step we do in our ligation protocol. Before doing the reaction, I'm going to bring your attention to this gel. This is the electrophoresis gel for the samples JAK-A and JAK-B that I purified in the previous week. So here are the 2 samples, and here is my ladder, new negative control, old negative control, my 2 JAK samples, Arabidopsis and PGAP. Now if you pay attention at the bottom of that page where you have step 3, it reads, if the PCR product was not as intense as the 1 kb band in the molecular weight marker in the agarose gel analysis from your nested PCR results, increase the amount of PCR product added to the blunting reaction to 2 microliters. You will also need to decrease the volume of sterile water to 1.5 microliters to compensate. So pretty much we're ending up with the same volume. So we're still going to end up with 9 microliters of volume, but we have to compensate for the amount of PCR reaction volume that we use, so we have to decrease the water. So if we pay attention to our 1 kb mark there, you can see the band is right here, so I've circled it in black, and it's as intense as these bands here. Maybe they're a little lighter, but not by much. So we're gonna keep these 1 to 1. So I'm gonna follow the protocol as it reads. You also see here this very strong band for JAK-B. This is actually more intense, which means there's more DNA here than in the 1 kb band, but the protocol does not refer to lessening the amount of PCR product, so we're also going to keep this 1 to 1. Should these bands be even more faint than your 1 kb band, then you would increase your PCR product to 2. And the reason for this is to keep the ligation reaction, which will be the next step, at a 1 to 1 ratio. So vector to fragment, PCR fragment or GAPC fragment at a 1 to 1 ratio. And we'll talk more about that in lecture. So once I've decided what amount I'm going to load, I decided to keep both of them 1 to 1. I'm going to go ahead and add everything in this box as detailed here. So I'm going to go ahead and use my P2 first to add 1 microliter of my purified PCR product. So you can see there I have my P2 set at 1 microliter. I'm gonna go ahead and make sure I give these a good mix, and I spin them down as well. So I'm just gonna flick them to mix them. And I'm going to just quickly centrifuge them to bring everything down. So I'm going to put this at max speed. it reaches max speed, that's enough for just bringing the contents down. So we'll go ahead and do that. So I have my jack A and my jack B here. I'm gonna add, I'll open these up. I'm gonna add 1 microliter of jack A to my A ligation reaction. Now, because the volumes are so small, I want to make sure I really wash off that pipette and get all my DNA in there. Now I'll go ahead and do jack B. Here is my jack B. So again, wash the tip a couple times, make sure we get everything in there. The next thing I need to add is sterile water. So because I'm following the original protocol, I'm going to do 2.5 microliters of sterile water. So I will use a P10 to do this. Let me set my pipette at 2.5. There it is. Now go ahead and add the sterile water to both reactions. Again, I'm gonna wash off the pipette tip to make sure I get all that water down. We're working with very small volume today, so I want to make sure I don't lose any of it today. And the same thing to my jack B. The last thing I'm going to add for my proofreading reaction is my proofreading polymerase. Now your protocol calls for 0.5 microliters of proofreading polymerase. So I'm going to go ahead and set my pipette at 0.5 microliters. And I have here my proofreading polymerase. Like everything, you want to make sure you spin everything down before you use it. So I'm just going to spin down my proofreading polymerase. Balance the centrifuge. Make sure I get the right one. This is proofreading polymerase. So I'm gonna go ahead and pipette out 0.5 microliters of proofreading polymerase. .5 microliter goes to my jack A. Again, mix really well. Make sure you get everything out. And 0.5 microliters of proofreading polymerase goes into my jack B. This back on nice. So I've added everything that I need to add for the blunting reaction to be successful. You can see how small the volume is, so we have to make sure again that we keep this volume down. So we want to centrifuge and we want to mix really well to make sure that everything is fully mixed. So we're gonna go ahead and mix. And then I'm going to centrifuge using this PCR centrifuge. So I'll actually let this round run a little longer than usual just because the volume is so small. If your proofreading polymerase stays on the top of the tube and the rest of your reaction is at the bottom, do you think your reaction would be successful? Probably not, right? How is the polymerase going to work on your GAPC product if it's not even in the same space? So I'm going to walk over to the PCR machine because the next step calls for incubating your samples at 70 degrees Celsius for 5 minutes. So I have here the thermocycler. I'm going to do a block temperature of 70 degrees for 5 minutes. That's going to activate the polymerase, and it's gonna allow it to remove those 3' A's, adenosines that it added at the end of the PCR fragment. So I'm gonna go ahead and run that for 5 minutes, and after that we can continue our protocol. Okay, my incubation at 70 degrees Celsius is almost done, and so I have here my ice bucket because the next step is to cool on ice for 2 minutes. Now this step is very important because we're working with a very small volume. We want to give this reaction, give the time to recondense the water vapor to maintain the reaction volume. So this step is very important. So I already have my ice here ready to get my samples. So this means my reaction is done. I'm gonna go ahead and take my 2 ligation reactions, and it's very hard to see, but you can see some water condensation here. So I'm gonna put these on ice for 2 minutes. Now I have my timer here ready to go, so I will see you in 2 minutes. Alright, so 2 minutes have gone by, and that has allowed my reactions to recondense and to regain all that water vapor that otherwise we would have lost. So now I can go ahead and centrifuge these to again make sure we bring all the contents down, especially the water. So you still have, just because you recondense the water, that doesn't mean that the water went down to the bottom of the tube where the rest of the reaction is, right? So we're gonna go ahead and centrifuge this down to bring all the contents down to the bottom. And I'm also gonna go ahead and spin down my blunted vector and my T4 ligase, as we're going to do ligation will be our next step. So I'm gonna go ahead and do that at the same time. Let that run. I'll stop this one. So now I can tubes out, and I can see that the volume has been brought down. So this is B, this is A right here. Stop this. Okay, so the next step in my protocol is to set up the ligation reaction. I already have the 9 microliters of blunting reaction in my microcentrifuge tube. So all I need to do is add my T4 ligase and my blunted vector. I'm doing step 9, where you have this table here. So I'm gonna grab my P2. This is already set up at 0.5 microliters. So I'm gonna go ahead and add the T4 ligase first. So again, we're working with very small volumes, so we want to make sure that we get everything into my reaction. So I'm gonna wash out the tip, make sure I get everything out. There's that sample. Let's do my next one. So I've added T4 ligase. Now I'm going to add my blunted vector. So that is also 0.5 microliters. And you can see, I don't know if you guys can see, but 0.5 microliters is not a lot. It's very minimal volume. So again, wash out that so you can get all the contents out of the tip. Let's do my Jack B. So now we've added a total volume of 1 microliter, so our total volume here is 10 microliters, right? We started with 9, we added 0.5 of T4 ligase, 0.5 of the blunted vector. Now we have a total volume of 10 microliters. Still not a very large volume, right? The next step is to close the caps and mix well and centrifuge briefly. So we're gonna go ahead and vortex those. Now, by now you know ligation is a very inefficient process, and so mixing well is gonna ensure that the ligase has the ability to join this vector and this fragment together, right? Whereas if all your vectors over here and all your fragments over here, then ligase really can't join them together. So this is an important step to mix everything well, and also to bring everything down to the bottom of the PCR tube. Now ligation occurs at room temperature. That means that T4 ligase is active at room temperature. So all we have to do is leave these, your protocol calls for 5 to 10 minutes. I'm going to do 10-minute timer. Once this is done, then I can go ahead and store these at -20 for our next experiment, which would be transformation.